Python is an object-oriented programming language, meaning that it primarily involves creating and manipulating objects. For example, we might create a circle as an object and define certain characteristics, like its radius and circumference. We can then extend this concept to other objects, such as the images we use for fMRI analysis. In the previous chapter, we learned the basics of Jupyter Notebooks and began with assigning a value to a variable. We now proceed to other types of variables, specifically built-in ones that come with Python by default, and the most common ones are integers, strings, and Booleans. From our Neurodesk interface, click on that plus sign and then select a new Python Conda environment. This will open up a new Jupyter Notebook. Let's begin with integers. These are whole numbers. In other words, they're not fractions or numbers that contain a decimal. For example, you can assign integers to a variable using the method in the last chapter. We have 3 classes and 20 students per class. These can be manipulated using any kind of arithmetic operation, such as multiplication. Also notice here that as you're typing a variable name, you can hit the tab key and then hit enter when it shows the name of the variable you wish to autocomplete. We can also divide variables by using the / character, which in this case, if we use the print command, will return a number with a decimal indicating that it is a different kind of type called a float. You can also use Python's type command to determine what type a variable is. For example, we could type, then in parentheses, num classes, and that is an int or integer type. The same thing for students per class. We find that it is a float because it contains a decimal. Note how the type changes depending on whether the variable contains a decimal point or not. If it does, it will be a float. If it does not, it will be an integer. Another important built-in type is the string. These are sequences of characters, and they are usually the same thing as words. You can assign a string to a variable the same way we did with integers. For example, a new variable job, and on the right side of the equal sign, in double quotes, we type Neuroimager. If we want to know the length or how many characters are in that word, Neuroimager, we can use the len command. There are other methods we can use as well, such as job.upper, which will capitalize all the characters, job.lower, which makes everything lowercase, or job.capitalize, which capitalizes the first character in the word. Note that these are all dot notation. These are methods that are appended to the object that they are modifying. You can also, for example, return the number of R's that occur in Neuroimager by typing job.count and then in parentheses, in quotes, the character R. The last basic data type is the Boolean, which can contain one of 2 values, true or false. For example, they are useful for determining whether a condition is met or whether a directory already exists before anything else is performed. You could, for example, set a certain state to true or false, like studying Python now equals true. Or you can use comparison operators to test a claim. In this case, is less than 10 equals len Andy, and then the less than sign, 10. If we use the print command, this will return whether that Boolean is true or false. To test whether 2 variables are equivalent, we use the double equal sign operator, a very common way to test for Booleans. So for example, I could say my name is Andy, your name is Bill, and then test whether my name is equal to your name. If we use the print for same name, this will return false because my name is not the same as your name. Andy is different from Bill. Lastly, you can check whether several tests are simultaneously true. Note that if only one of them is false, then the output will return false. So here in parentheses we have is hello in my name, and in another set of parentheses, is 2 times 5 greater than 8? And the last set of parentheses is starting Python now equivalent to true. Because only one of them is false, the entire set will be returned as false. We now move on to collections. So far, we've declared a few variables, and they're easy enough to remember and to work with. But when you begin working with larger data sets with many dozens or hundreds of variables, you'll need to make sure that they are organized appropriately. We can do this using collections, which are data structures that contain variables and other objects. The most common type of collection is called a list, but we'll explore a few other options as well. The list collection can contain any number of different types of objects, strings, integers, and even other lists. For example, we could place these all within a list. There are 3 strings and 2 numbers. Note that the list is enclosed in brackets and that this list contains different data types. If you want to retrieve any of the items, also known as elements, within the list, you can do so with brackets. For example, mylist brackets 1 will return Andy. Note that Python uses zero-based indexing, in which the first element in the list is indexed with 0. You can also use colons with the bracket notation in order to retrieve more than one element. In this example, note that the third element in the list, indexed by 2, is not returned, since that side of the colon represents the stopping point of items to return. You can adjust the range as needed. To create a nested list, let's create another list, appropriately called another list, with 3 items in this case. We can join this together with our previous list. Let's call this nested list, and in brackets, we can put in mylist, comma, and then another list that we just created. We can now call upon any one of these lists, such as another list, using index notation. And if we want to retrieve one of the elements within that list, we use another set of brackets, one adjacent to the next. In this case, retrieving the first element from the second list. The dictionary object is a data structure similar to the kinds of structures found in MATLAB. You can also think of a dictionary in Python as like a book dictionary. Each entry in the dictionary has a corresponding definition. Python dictionaries are organized by pairings of keys and values in which the keys have unique names, but the values can be the same between keys. As an example, let's say we create a dictionary representing the header information inside an fMRI dataset. This might contain parameters such as the TR, the voxel dimensions, and the number of volumes. We create this dictionary inside of curly braces with a colon separating each key value pair, and also a comma at the end of each line for each of these key value pairings. If you just type the dictionary name, it returns all of the key value pairings. You can also retrieve a single value by typing its corresponding key. For example, fMRI image, and then in brackets and single quotes, TR. If you want, you can add to the dictionary by creating a new entry. Using our same fMRI image dictionary, in brackets, we can specify orientation equals RPA. You can also overwrite one of the entries in the dictionary by retrieving, say, TR, and then assigning it a new value. You can see these updated values by typing the dictionary name. The last type of collection we'll talk about today is a tuple, which is an immutable list. In other words, once you create the tuple, you can't change what's inside it. To create a tuple, use parentheses instead of brackets. For example, my tuple equals hello, 95, and a plus. If you try to overwrite any of these values, it will throw an error. We can't do the same thing that we've done with dictionaries and lists, for example. However, you can convert a tuple to a list by using the list command. In this case, assigning a new list by simply converting my tuple. If we look at the new one, this will be a list, and we can change any of the elements in this list now and see the result here. We have covered some of the basic data types of Python, which are used in virtually any code that you will come across. In the following videos, we will review more advanced aspects of Python, including control statements, functions, and classes, which give you greater flexibility for what your code can do.